All right, everyone, it's big brain hours. I'm feeling a little smug right now, so I want to show off my big brain ability, and obviously this is meant to sound very condescending. So I'm doing a trig class, not really because I don't know trig, but it was more in hopes of refreshing my skills, and honestly I think I would have been better off not taking this class. So I could have taken something else, but whatever. It is what it is, so I'm kind of stuck here. I have to pass the class anyway, since it's too late to drop it. So right now, I was working on the question. No. Okay. Verify. There we go. Verify that cosine of 4 theta equals 8 of cosine theta to the 4th power minus 8 cosine squared of theta plus 1. So, my original attempt was to use the angle addition formula where you have cosine of alpha plus beta. So you can resolve cosine of 4 theta into cosine of 3 theta plus theta, where all of this is all one argument for theta, or for cosine, excuse me. And then you can use the addition subtraction formula, which is cosine alpha cosine beta minus sine alpha sine beta if you're adding the two angles. And I'm pretty sure I made a mistake in here somewhere because I've got this website open that I love a lot. It's called Desmos. It's a free online graphing calculator. You've got no ads to worry about, and you can use it as long as you want for free. It's fantastic. The only thing that gets better about it is when you sign in, you can store all of these as a graph, or I guess all of these are graphs. Right now I'm not signed in, but give me a second. Hold on a second, I'm gonna sign in and try not to dox myself. There we go. So I'm gonna name this poop. And now it's in my list of saved graphs, so I can look back at this at any time. So that's cool. But this is also a really easy way to check. You can use it as a basic calculator. So let's just do 2 plus 3. And you can see 2 plus 3 is in fact 5. And you can also use it to check things that you think might be equivalent. So let's do sine of 2x. Apparently we're doing s now. And I'm going to check to make sure that the identity is true, that sine of 2x is 2 times sine of x times cosine of x. Oh, I need to try this. There we go. And you can see a solid green line here at, I think this is supposed to be y equals 0, which means this is always 0. So it is true. These two things are the same. So you can do what I'm doing for your trig class, or whatever you might be doing, where if you get the same graph, you can see that two things are identical. So you can see I've made this red graph invisible. And then when I re-enable it, it completely covers up the black graph, which means they must be the same thing. So how did I end up solving or verifying this, and why do I feel so smug about it? Come on, autofocus for me, please. So I noticed that if you change theta to equal 1/2 x, then you would get the half angle identities. And sure enough, if we go through all of this crap, you'll find that the left-hand side, since we substituted x for 2 theta, this now equals cosine of 2x. And that was just a bonus thing that I wrote down. And then you have to prove that the right-hand side, which is this area also equals to cosine of 2x. So if you don't believe my work, that's what I have this here for. So this line is obviously cosine of 2x, and this line is the way I have entered it into Desmos. And as I showed before, these are the same. So I think this is the transitive property. If you have A equals B and B equals C, then A equals C. So that means we have the left-hand side equals the right-hand side. Of course, I technically need to go back and resubstitute in my variables, but I think this is good enough. So flex over, I guess,